everyone, welcome back to Let's Code to be a Java Programmer. Today is day 20 of our coding journey. In today's session, we'll dive into the concepts of stack and heap memory in the Java virtual machine. Understanding how memory is managed in Java is crucial for writing efficient code. Let's get started. Now let's see how memory is being saved in JVM. So basically we have a layer of JDK. Then inside the JDK we have JRE, and inside JRE we have JVM. For now let's have JVM alone. Okay, so this is JVM. Now in JVM, how the memory is being saved. So we are gonna talk about this in today's session. So we have two things basically inside JVM, okay, for the storage purpose. One looks like this, something like this. Then this is how one structure looks like, and the other structure looks like this. Mm. Somewhat randomly like this. Okay, so can you all just guess what these structures would be and what would be the name of this? Yes, this is stack. People coming from other languages might be aware of the stack, and this is heap. Okay, so inside JVM we have these two things, stack and heap. Okay, so the variables what we are creating gets stored inside the stack. Okay, now let's say I have numbers like 2, 3, 4. Okay, since I am sending 2 first inside the stack, the 2 gets stored here. And the 3 gets stored there. And since I'm sending it last, it will be at the last record. Okay, so this is how it is. Now let me erase it. So in this order only we save anything inside stack. Okay, so first inside will be the last one coming out. That's only known as first in first out. Okay, so now let's get into this program what we have run last time. Let me remove this for now sake. Okay, now this stack, there's not only one stack inside the JVM. Okay, we have multiple stack, and this number of stacks depends on how many methods we have inside the program. Okay, now let me also create another stack, or wait, let me do this. Okay, so there is two stack here. This is stack 1 and stack 2. Now why we have two stacks? Because this program has two methods. Okay, so for each method we have each stack allocated for that particular method. Now since our program starts here, this is the main method. This would be the stack for this main method, and this is a method called add, which is inside this calc class, and this would be for add. Okay, let me note it down at the side so that you would be aware. This is for add and this is for main method. Okay, okay, it corresponds this one. Now, how does this variables inside the methods get stored? Now let's have a look at it. Firstly, we haven't declared any variable here except res. It's okay. Uh, since res is a variable, we will be storing res here. Okay, since this is the starting point of the method, and as we come, this is the only variable what we have. And also one more thing to tell, the structure of stack would be like this. It consists of two columns and number of records. Okay, now let me tell you the reason why it has two columns. Now let's say I have something here as int a is equal to 2. Okay, since a is equal to 2 here, inside this first main method, the variable gets stored like this. A inside this and 2 inside this. So this is how usually the variables get stored inside JVM in the form of stacks in their own separate methods. Okay, so each stack consists of two columns and the multiple number of records as per their needs, and this is how they get stored. Now we have something called obj, right? Okay, now let's come to this as the last part. Now we also have two variables here, that is a and b. Okay, so these are known as local variables, and these local variables also gets stored inside their respective stacks. A gets stored here, and of course B also gets stored here in the same way. Now this is known as local variable because you can use it inside this method anywhere. Now what if I declare a variable here, say ntg? Okay, now this variable ntg is known as a instance variable. So this instance variable will not be stored in the stack. Instead, it will be stored inside this JVM. Okay. Now, how it will be stored is it gets stored in the form of table again, but not with the two columns, with one single column. So now this box, in the same way, has a multiple number of rows like this. And this mtg, since it is an instance variable, it gets stored here. Okay, so this is how the instance variable gets stored. Now this is instance variable and this is local variable. Local variables will always have a place inside the stack of that particular method, whereas instance variable gets stored inside the heap. Okay, and here of course a is also a local variable, so we have stored it here. Now let's talk about this obj. Now what is this obj? Obj is the object which we have created. Okay, now how does this one get stored? Okay, so obj is known as reference variable. So we have seen about local variable, instance variable. Now where does this reference variable be stored? Of course, reference variable will also be stored here inside the stack. It gets stored here inside the stack. But correspondingly, what value does it have in order for me to store it here? Mm, nothing, right? It just goes and calls a calci. So what happens now is, since it calls a calci, a table here gets prepared for calci, and the instance variables here get stored. And of course, this table has some address. It's actually a complex address. For now sake, let me store it as something like 1011. So this address gets stored here obj. So whenever obj is called, it goes to the address of 1011. Okay. Now this is how it's working basically. And after obj, we also have something called res. Okay. Now where does this res go? Res goes to obj inside the method of add. So it goes to a, and it has passed some parameters, right? 3. So it stores 3 here. Rest gets saved here. Since it has called obj 1011, it goes to this, and since it is inside the method of add, it goes and gives the parameters which has been passed here, 3 and 4. Now again the b which is here gets the value 4. Now this is how heap and stack gets stored inside JVM. Now also, it's not necessary that you're supposed to create only one object for a method. You can also create two objects for a method. Now let me show you. It's another object. What shall we create? Okay, calci obj2. Now this is the second object which I'm creating for the very same class. Okay. Now with this, int answer. So this answer is gonna give me the obj2 dot add of the same parameters I'm passing, the same values. Okay, control S. And I'm also gonna print answer. Okay, control S. I'm gonna run, compile, then run. Okay, since I haven't given a println, it has given me the answer as 77. That's not an issue. Now let's change. Control S. Yes, that's perfectly correct. Now, let me change this obj.add as okay. Instead of printing this obj add, let me directly put here obj add. Let's see what it would happen. Control S. It still gives me the same answer. Okay. Okay, so let me change the parameters which I am passing. Now, if I'm changing the parameters here for the second object for which I am passing, let's see whether the values are getting changed or are we getting the same one. We are getting two different answers because the different objects are passing different parameters inside the same method. So it gives obviously different answers. Okay, I hope you understand. And this is how the stack and JVM works. I mean, the storage of JVM memory works with the help of stack and heap. Thank you. That's all for day 20. Today we learned about stack and heap memory in JVM. Thank you for joining me on day 20 of Let's Code to be a Java programmer. If you found this video helpful, please like, subscribe, and hit the bell icon to get notified about our daily coding sessions. See you tomorrow for day 21. Happy coding!